Hello everyone, welcome to this video on learning mathematics through concepts and examples. Today we are going to look at some problems on related rate. Okay, let's get started with the first problem here. If the radius of the circle is r, then the area of the circle is given by this formula. A is equal to pi r squared. That's a well-known formula for you. The area of the circle increases at the rate of 2 centimeters squared per second. How fast is the radius changing when the radius is 4 centimeter? So what is given here is the radius is increasing. The area is increasing. You can see the area of the circle increases at the rate of 2 centimeters squared per second. That is change in area with respect to time. dA over dt is 2 centimeters squared per second. We have to find how fast is the radius changing. How fast is the radius changing? So we are looking for change in radius, dr over dt. And we are doing this calculation when radius is 4 centimeter. So the value of the radius is 4. Okay, so let's get started with the given formula. If the formula is not given, you'll write it yourself because this is a known formula. So we know the area of circle is equal to pi times r squared. Now, because we are talking about the rate, we need the derivatives with respect to time. So we are going to find the derivative with respect to time. So if we differentiate this with respect to time, left-hand side will be dA over dt is equal to pi is a constant. And the derivative of r squared is 2r times dr over dt. If we use the implicit differentiation, we multiply by the quantity dr over dt. Now, we can plug in all the values that we know. dA over dt is given, that's 2. And then 2 times pi, that is 2 pi, multiplied to the value of r is 4, multiplied to dr over dt. Now, in order to find the value of dr over dt, we can divide on both sides by this quantity, which is 8 pi, 4 times 2, 8 pi. So we can divide on both sides by 8 pi, 8 pi, 8 pi. So if we do that, here, 2 over 8 is same as 1/4. So we end up getting 1 over 4 pi. 1 over 4 pi. These two are the exact same value. So they divide to give you 1. And we are left with dr over dt. dr over dt. So meaning of that is we get dr over dt positive. That is, the radius is increasing, right? How fast is the radius changing? The question has the word changing. That is, we don't know whether it was increasing or decreasing. But here we get the rate positive. Meaning of that is the radius is increasing at this rate. So we can say that the radius is increasing. Okay. Radius is increasing at a rate of 1 over 4 pi. We have to write the unit. Unit of radius is centimeter, right? As it is given in the problem. And we have the time in seconds. So radius per second. So that is centimeter per second. So the radius is increasing at the rate of 1 over 4 pi centimeter per second. Okay, that is our first example. Now we'll move on to second example. Here is our second example. Let's find out what is going on here. A ladder 10 feet long rests against a vertical wall. Okay. So what is going on here is there is a wall. There is a wall, maybe somewhere there. There is a wall, and say that this is the ground. And there is a ladder. There is a ladder that leans against the ground, just like that. Okay. And this ladder is 10 feet long. This is 10 feet long. Let's consider the distance from the bottom of the wall to the bottom of the ladder as x, and the height of this one, or distance from the bottom to the top of the ladder, is, say for example, that is y. And you can see that that forms a right triangle there. Okay, 10 feet long ladder rests against the wall. If the bottom of the ladder slides away from the wall at the rate of 1 feet per second, so this ladder is sliding away. Okay, the ladder is sliding away from the base like that at the rate of 1 feet per second. So if the base of the ladder is sliding away, the value of x is increasing. That means this is dx over dt, which is also a positive. Dx over dt is 1 feet per second. Now, by doing that, what happened is the top of the ladder will slide down. Top of the ladder will slide down. Now, we have to find how fast is the top of the ladder sliding down. How fast is the top of the ladder sliding down? So we need dy over dt, that is equal to how much? Okay, and look like this y is decreasing. That means the rate must be negative. That's what we can think from here. Okay, and we'll do the calculation and get that. And we are doing this calculation when the bottom of the ladder is 6 feet away from the wall. So we are doing this calculation when this distance is 6. We are doing this when x is equal to 6. Okay, first of all, what we can do is when x is 6, what is y? Let's find that. When x is equal to 6, we have, if we use the Pythagoras theorem here, x squared, that is 6 squared, plus y squared equal to 10 squared. So y squared is equal to 10 squared is 100, 6 squared is 36. Now, 100 minus 36 is 64. So y squared equal to 64, meaning of that is y is equal to 8. Okay, 8 feet. That means we are doing the calculation when x equal to 6 and y equal to 8. Okay, now let's write the equation for this right triangle. We have two sides unknown and one side is 10. So the equation will be the Pythagoras theorem, right? Which is x squared plus y squared equal to 10. X squared plus y squared equal to 10 squared. We can differentiate on both sides with respect to time. So if you differentiate x squared with respect to time, you get 2x times dx over dt. If you differentiate y squared with respect to time, you get 2y times dy over dt. And the derivative of constant, derivative of this 100 is 0. We want to find dy over dt, so we move this quantity to the right-hand side. So we get 2y dy over dt is equal to negative 2x dx over dt. Because we want to find dy over dt, so we move this quantity to the other side, and we subtracted that quantity on both sides. Now we can divide on both sides by 2y and find dy over dx. So if I divide here by 2y and also here by 2y, let's see what we get. We end up getting dy over dt equal to, okay, that is a negative, 2 and 2 cancel, negative x over y. X is 6, y is 8. So 6 over 8 multiplied with dx over dt. Dx over dt is 1. Okay, or this is same as negative 3/4. Meaning of that is the ladder is sliding down at the rate of 3/4 feet per second. So we say top of the ladder. So top of the ladder is sliding down. Okay, it is sliding down because meaning of that negative sign is it is sliding down at a rate of at a rate of 3 over 4. 3 over 4, and unit of length is feet here, and time is second. So 3 over 4 feet per second. So the top of the ladder is sliding down at the rate of 3/4 feet per second. Okay, so in this video, we are going to solve one more problem. So let's move on to the last problem here. Here we go. If the radius of the ball is r, then the volume of the ball is given by this formula. Okay, the volume of a sphere is V equal to 4 over 3 pi r cubed. You know this. Air is being pumped into a spherical balloon, which is just like the ball, okay, spherical balloon, so that the volume is increasing, right? So that its volume increases at the rate of 100 centimeter cubed per second. So that is dV over dt. dV over dt, change in volume with respect to time, is 100 centimeter cubed per second. That means the radius is measured in centimeter, time is measured in second. And remember, we are talking about the radius here. The formula is in terms of radius. How fast is the radius of the balloon increasing? So how fast is the radius increasing means dr over dt is how much? We say it is increasing, so that means we have to get a positive value. And we are doing this calculation when the diameter of the balloon is 5 centimeters. So diameter is 5, meaning of that is radius is equal to 5 half. Okay, diameter is 5, meaning of that is radius is 5 half. We must have the same quantity everywhere. If we are calculating radius, here we need the radius. So diameter is 5, so radius is that. Okay, let's begin with the formula. We have volume is equal to 4 over 3 pi r cubed. We are calculating the rate, so we have to differentiate on both sides with respect to time. So dV over dt is equal to 4 over 3 multiplied to pi is a constant. Derivative of r cubed is 3r squared dr over dt. Now what we can do here is, you can see that we have 3 in the denominator, 3 in the numerator, that get cancelled, and we can plug in the values. dV over dt is 100 equal to 4 pi multiplied to the radius squared. Radius is 5 over 2, and square of 5 over 2 is 25 over 4. This is our 4 pi, right? And then the radius is 25. I mean, radius is 5 over 2. So square of 5 is 25, and the square of 2 is 4. So square of 5 over 2 will be 25 over 4. Okay. Once we do that, let's write that dr over dt. Once we do that, we can simplify this a little bit. Again, these two get canceled. So what we get is 100 is equal to 25 pi dr over dt. Now what we need to do is, in order to find dr over dt, we need to divide on both sides by 25 pi. So this implies dr over dt is equal to, you are dividing that 100 by 25 pi. 25 pi, because we are dividing here by 25 pi and also here by 25 pi. So the 25 pi on the right hand side get cancelled, right? And we are just left with 100 over 25 pi. And that can be simplified. dr over dt is equal to 100 divided by 25 is 4 in the numerator and pi in the denominator. So that is the rate at which the radius is increasing. So we can say that the radius is increasing at the rate of 4 over pi centimeter per second. So we write the radius is increasing at a rate of at a rate of 4 over pi 4 over pi centimeter per second. So this is how we can solve some of the related rate problems. Okay, that's all in this video. Thank you so much for watching.